So this is my array-based Deque class. We have the max size field, which is set to 5, and then we have elements, front, and size. This is the constructor, which is creating an instance of an object array, and then we are casting the anyType type parameter to the object, and the array is going to be the size of the max size field. Front is going to be -1 and size is going to be 0. We have the size method here, which is just going to return the value of the size field. And then we have the getRear and getNextRear methods that I implemented. The getRear will return the position of the current rear, so it's front plus size -1 divided by max size, and then the remainder of this will be returned, and that's the position of the current rear. And then the getNextRear is just front plus size divided by max size, and then the remainder of this will be returned, and that's the position of the next rear. And then isFull will determine if the size is equal to the max size, and if it is, it'll return true, and if it's not, it'll return false. And then we have the clear method here, which will change the front value to be -1 and size to be 0. IsEmpty will determine if the Deque is empty or not by comparing the size to 0. And then we have the expand method. So we are creating an array that is twice the current max size value. And then a for loop is going to iterate through the previous array and copy all the elements from the previous array to the new array. And then we're just going to now reference the new array. We're going to change the max size field to be twice what it previously was, and then our new front position is going to be 0. And then we have the addFirst method here, so it's going to check if the Deque is full, and if it is full, it's going to call the expand function to create a new array twice the size. So then we have more, now we have available space to add another value to it. We have a if statement here to determine if front is equal to -1, which would mean that the Deque is empty, so therefore we are going to increase the front by 1 and then place the value of x into that position. If the value of front is 0, then that means we're going to have to loop to the end of the array and place the value of x into that position. So we are now going to make front to be the max size -1, which will give us that last position of the Deque, and then our x will be placed there. Otherwise, we are just going to decrease the front by 1 and then place the x value there. And then obviously our size will be increased by 1 because we are adding an element. Then we have the add last method here, so we're going to check if the Deque is full. If it is, we're going to expand it. We're going to check if the front is equal to -1, which means that it's empty, and then we're going to increase our front by 1, and then we are going to we're going to call the getNextRear method to determine the position of the next possible rear position, and then we're going to place x at that location, and then we're going to increase our size by 1 because we are adding another value to our array. So here we have the removeFirst method. We have an if statement that's going to check if the Deque is empty or not, and if it is, it's going to throw the no such element exception. Otherwise, we are going to create this removed element field of type anyType and place the element at the front position into this field. And then we're going to update our front to be front plus 1 divided by max size. And then the remainder of this is then going to be the new front position. This is going to account for the nature of the circular array. We're going to decrease the size by 1, and then we're going to return that removed element. Then we have the remove last method. We're checking to see if it's empty. If it is, it's going to throw this exception. If it's not, it's going to call the getRear method, and then the position that is returned is going to be the position of the element that is going to be removed. So we decrease the size by 1, and then if the size is equal to 0, we are going to change our front to be -1, which means that the deck is now empty, and then we're just going to return that removed element that we placed in the field earlier. And then we have the get method, which will take in an integer value that will be the index of the item that we will be returning. So we have an if statement here to determine if the index is even within the if the index is out of bounds or not. So if it's negative or if it's greater than the size of the array, then it's going to throw this index out of bounds exception. Otherwise, so to account for the front value not being constrained to index 0, we are going to take the index that was passed plus the front divided by max size, and the remainder of this is now going to be the new index value. It's going to be the index value relative to our front position, so then the item that is at this position will be returned. We have the getLast method, which will just determine if the deck is empty or not, and then we will return the item at the position that the getRear method returns to us. We have a getFirst method, which is just going to determine if it's empty. If it's not, then it'll return the element at the front position. And then we have a toString method, which starts with an open bracket. We're initializing our index field to be that of the front value, and i equals 0. And then we have a while loop here. That's just going to iterate through the entire array, and then it's going to append the value of the item starting at the front to the output, and then we're going to increase the index by 1, and then also, increase the index by 1 relative to the max size, because we have a circular array, so it's going to, this modulus operator is going to account for that, for the nature of a circular array, and then we are going to increase our I by 1 each time, so we have the while loop. It's going to iterate through the entire array, and then once we exit out of the while loop, if the size is not equal to 0, that means we still have one element at the rear position, and if it is 0, then it's not going to perform this statement, and then we are going to return our output plus the closing bracket. So yeah, this is my array-based deck class. Thank you.